Hi all, thanks for joining my session. Today I'm going to talk about using Python to declare and deploy your cloud infrastructure, all using a library called Pulumi. So before we start, a little bit about me. I run a data and AI agency, and we build data platforms and products, and more AI native products as well. So if you have any thoughts, conversation starters on data or AI, please track me down. Okay, so what is the problem? The big T is the problem. Who's used Terraform in the past? Okay, quite a lot of you. And who's enjoyed using Terraform? Oh, that's good. There's a few Terraform supporters there. I really don't like it because it feels like every time I use it, I have to relearn some fundamentals, and there's lots of artifacts of that configuration language, which are unique to that language, and trying to get around things that you take for granted in other programming languages. Pulumi approaches the problem in a slightly different way. Pulumi offers a range of language SDKs you can use to configure your infrastructure. And of course, our favorite one is Python. It is free and open source. They have a managed platform called Pulumi Cloud, but you can get away without using it. And if you use it, I think their free tier is quite generous as well. So today we'll see how you can manage your cloud infrastructure and deployment of that infrastructure using Pulumi completely on GCP. So there's no sort of costs involved other than your cloud costs. So what does using Python to describe your infrastructure give you? It gives you all of the things that we're really familiar with in the software engineering world: loops, conditionals, functions, classes. And increasingly, your infrastructure can start to look very much like your source code as well. Additionally, you've got all of the benefits of bringing in your IDE tooling and general Python tooling as well into your infrastructure. So there's lots of benefits, and in this talk we'll just sort of run through some of these concepts. Now, Pulumi styles themselves as a development, IAC platform, infrastructure as code platform. What that really means is there are three components to Pulumi. There's the downloadable CLI, there's the client SDK, so you can write your infrastructure in JavaScript, TypeScript, C#, Java, Python, and I think even YAML if that sort of thing appeals to you. And combined, these three things allow you to provision, update, and manage your cloud infrastructure. The other nice thing about Pulumi is combined between the official providers and community curated providers, there's over 300 cloud platforms supported. So there's sort of every flavor of cloud deployment you can think of, and adding a new provider to an established project is as simple as, well, if you use UV add Pulumi Snowflake, for example. Okay, so the setup. Let's do some learning. First thing is the CLI installation. So you've got a brew install pathway for Mac. Linux, you install a shell script, and for Windows, you can do a direct download of some binaries. To initialize a Pulumi project, like with Terraform, you need something to store the state. That state can be stored in a number of backends. So anything that's S3's API compatible will work. Google Cloud Storage, Pulumi Cloud already mentioned, but you can also use PostgreSDB and a local file system. And here I'm going to say don't use a local file system even if you're testing things out, because at some point you'll always want to migrate to the cloud. So you'll need to create a GCS bucket outside of Pulumi, and that means this particular resource won't be managed by Pulumi, and you need that because you want this bucket to be protected from any accidental changes. Now you think you can, you're able to initialize Pulumi, but there's one additional step for GCP. With GCP, not all services are enabled by default, and so the best thing to do is to enable any service you think you're going to use prior to starting the Pulumi project. I run a script for every new GCP project, which enables all of the services I use the most. And then if there's any new ones, then those can be done manually. But until you enable these services, you won't be able to access them through Pulumi. Right, now back to the code. So we've got our state bucket. Now we need to authenticate with your Google Cloud project, and creating or initializing a Pulumi project now is as simple as writing Pulumi new. Or if you know that there's a specific template you want to use, Pulumi new and then the template name. Once you've got that template initialized, then you need to log into your bucket. Pulumi has this annoying habit of always trying to force you to log into their managed service, so remember to log into your state bucket to maintain state. I mentioned there was lots of templates. These are all the templates just for GCP. So they've got templates for all the language SDKs, but also things like a serverless GCP template and a VM template, static website template. I generally don't bother using some of these templates. I just start with the vanilla GCP Python. Right, and then kickstarting that command leads you through this workflow. So you need to specify a project name, project description, stack name, and we'll come to stacks in a bit, but you can think of them as environments for the time being, and then also the GCP project you want to link to. It's a GCP project is exactly the same as an AWS account, and then that's it. Your all of your dependencies get installed and your files get initialized, and this is what you end up with. So you start with a pulumi.yaml file, which is a project file, then a pulumi.development.yaml, so that is the environment file or stack file, and then your main.py, which is the entry point into your Python project. Project files contain the configuration for all of your Pulumi project, and it contains metadata. So, for example, you can see that we've used or I've specified UV to be used as the toolchain or the package manager. You can also add in. It also has the template that started this project off, but you can also add in additional configuration here, which will apply to all stacks in your project. Talking about stacks, so what is a stack? So a stack is analogous to an environment. So it's quite typical that you might have a development stack, a staging stack, and a production stack, and each stack is independent from the other stacks and has its own state. You can also configure each stack differently with different configuration variables. So the idea here is that you can have the same Pulumi project implemented in different environments. So the top image is the stack YAML, the development.yaml, and then bottom is what happens if you type in Pulumi stack. It gives you a list of all the resources that have been deployed to that stack, which is quite useful just to refresh your memory. So these are the commands you would generally use to interact with stacks. So stack init to create a stack, stack ls to list all your stacks, and then stack select, say dev, to choose a particular stack. Very simple commands, but they give you lots of ergonomics. Right, time to talk about state and backends. So Pulumi state records metadata about your infrastructure, so what it looked like after the last operation. Pulumi preview and Pulumi app commands compares the recorded state, so what's in that state file, with what you have in your program configuration. And finally, Pulumi refresh synchronizes Pulumi state with the actual state of deployed resources. So the idea here is that sometimes your cloud resources or cloud infrastructure might drift from what you have in your state file, Pulumi refresh will sync your state file to the state to the current condition of your deployed infrastructure. All right, so that's all the sort of fundamentals of Pulumi, but let's talk about a real project. So this is a subset of a larger project that we have, and the idea here is we want a couple of pipelines to move and transform data from GitHub and from Google Drive. So each pipeline should operate independently. Each pipeline should export data to a destination bucket, a different destination bucket, and all of this should run in GCP. Source code is contained within the repository. It's packaged up and pushed to GCP's artifact registry, and any sort of errors or logging and monitoring should happen natively within GCP, but any errors warnings should be sent to Slack. In addition, we want secrets handled via Secrets Manager, tightly scoped service accounts with IAM permissions, 2 environments, dev and prod. Dev, you should be able to deploy from a local machine, and prod should be deployed from CI/CD. And yeah, logging, monitoring, and alerting via Slack. So we've talked a lot about the sort of Pulumi ecosystem. What does a resource look like? So this code, sorry, it's a bit small, but this code is typical code for declaring a GCS bucket. So it's very simple and very Pythonic. You can see you've got all of the niceties of syntax highlighting, and also all of your IDE tooling as well will help you when you're writing this code. One thing to sort of be aware of, which is quite different to Terraform, is how Pulumi handles naming. So each resource must have a name. So in this instance, the name is GitHub-bucket, the string within the bucket resource. Pulumi takes that, by default, Pulumi takes that name and appends a hash to the end of that name. So when you see that bucket in your cloud platform in GCP, it will likely have a different suffix. The reason Pulumi does this is twofold. One is so that the same project, the same Pulumi project could, for example, be deployed in the same GCP project, and you can avoid namespace collision. The other is zero downtime deployment. So some resources will require that a resource is torn down before a change is made. Others will update in place. But for those that require the teardown, what Pulumi does, it'll create the new resource with a new name, with a new suffix, and then it'll tear down the old resource. So that means you shouldn't have any drop in service in uptime. And also, most importantly, you can suppress this if required. So there in the bottom code block, you can see some YAML that you could add to either project level or stack level YAML files, and that will mean that the logical name that you specify will be exactly the name that's used in the cloud. Inputs and outputs are how Pulumi builds its dependency graph. So in this image, you can see that we want to assign some bucket permissions to a service account, bucket permissions to a bucket, and assign them to a service account. By the use of inputs and outputs, so references to the object itself, Pulumi works out a dependency graph. So it will know that it needs to deploy the example bucket, it needs to deploy the example service account before it can create the bucket permissions. And so you will see this pattern of inputs and outputs quite regularly, and you can see some of that in the code coming up. But this is quite important because with inputs and outputs and state, those 3 concepts are how Pulumi manages to be declarative. Right, now back to the code. Okay, so we've talked about this pipeline, and this is the code that that declares all of the resources required for this pipeline. So you can see here we've got, of course, the GitHub bucket to start with, artifact repository. We're using a Docker provider from Pulumi to actually do all the packaging up and send that up to the artifact registry. And then we've got some permissions handled through service accounts, IAM roles, secrets, and then we get to the actual Cloud Run job. Now, this looks complicated, but actually, most of this complication is to do with the environment variables we want to send into the container. The actual base resource is quite simple. One thing I wanted to show is the use of an input here. So, okay, bucket writer IAM. Here you can see that it's actually waiting for the output of the service account email within this bucket writer IAM resource. So there is a direct link between both of those resources, and Pulumi will work out which needs to be deployed first and which comes second. And so, the thing to point out here is it's the output of the service account becomes the input into the bucket IAM resource. So we've got the Cloud Run and then how to actually execute it. So there's a schedule resource and a job invoker resource, which gives permission for that schedule to invoke the Cloud Run job. So that's really nice, but it is quite verbose. Monitoring and alerting, on the other hand, is a little bit simpler. Part of the setup you need to do in Slack, create a bot that can write into a notification channel and then pass the bot's OAuth token into GCP. And that way GCP can authenticate and write directly or send messages directly to your Slack channel. There are metrics and also notification channels that are required to get that working, and then also the alert policy. So what are the conditions that need to be met so that GCP will alert Slack in case of failure. So in this instance, it's if any Cloud Run job fails, then an error will be sent to Slack. Right. We talked previously about sort of the base configuration for Pulumi project. One thing that you might have seen is when we defined the secret, there were actually 3 different resources that needed to be created. So there was the secret itself, which is a placeholder. Then there is the value that's placed into the secret, and finally there's the permissions that need to be granted on that secret. So if you had to do that for every secret you wanted to create in GCP, that's 3 resources repeated constantly. A better pattern is actually to put that into either a class or a function, but refactor that out so that that becomes a single unit of resource creation. So every secret will be, every secret that's created will have each of those 3 resources created for it. You can see see how much that would simplify this work. So this is what it looks like. So rather than 3 resources in your main.py, you now have just a function call, and then to actually use it, you can use this native get secret version output to pull the latest value of the secret. So it's just normal Python. We can do the same for the pipeline itself. So all of the resources that we talked through before, the bucket, the artifact registry, even the Docker build and push process, service count, etc. That's all refactored into a single pipeline function. And that means that anytime you want to create a new pipeline, you just call that function. The thing that will change between different pipelines is the environment args you want to send into that container, but other than that, it's all contained within this function. Nice and simple, and much more concise. You'll also you might actually, I don't think it was in the main code block, but it also gives you an opportunity to use some conditional flow. So in this instance, we want the production pipelines to run every 3 hours, but let's say dev and staging can just run once a week. And this the native get stack function allows you to do this conditional flow based on the stack that you're operating at any one time. Project structure. All of this is contained within a monorepo, and so here we've got your GCP infra folder, which has all of your Pulumi project. You can see both the project and stack level YAMLs. So we've got 2 stacks, dev and prod. There are some scripts here that I use for initial setup, so enabling the APIs and some of the permissions, and then also the wrapper pipeline and wrapper secret modules that were the refactor. And then within your source code, you've got pipeline drive and pipeline get. So this is the source code. You can see all of the code, and the Docker file for each pipeline is contained within the same folder. So it makes for a really tight project structure and easy to sort of go through. Deploying to prod, always make sure that you use CI/CD, just so you don't have naughty developers pushing directly from their machine. In this instance, I've used GitHub Actions, and really the 2 things I want to call out are with GCP. I've used federated workload identity provider to authenticate between GitHub and GCP, and also created a service account that the CI/CD pipelines can use. Implementing all of the dependencies is through UV, and then actually the actual Pulumi bit is really simple because it just uses this Pulumi action, and so the command is Pulumi up, stack is prod, and working directory is GCP infra. So this is a really super simple GitHub action which deploys your latest changes to your production project on every push to the main branch. And finally, just to wrap up, I'm a big fan of Pulumi because of the simplicity. I find it's super simple to create reusable wrappers around like resources that commonly operate well together. And also you can work really easily in different cloud environments because we work with lots of different clients who have their own cloud preferences and choices. We need to be quite agile with the way that we deploy our products and platforms. So Pulumi really helps with that. The sort of list of commands that you might use day to day is really small. Really Pulumi Pulumi login to log into your backend, Pulumi stack select to select your the stack that you're operating in, Pulumi up to deploy changes, Pulumi refresh to refresh your state, and then very, very rarely, and hopefully not accidentally, Pulumi destroy to tear everything down. That's it. Thank you for listening to my talk on infrastructure in Python. If you'd like to connect, that's the QR code to our website. Yeah, and happy to talk through the rest of the conference on infrastructure, DevOps, data, AI, anything. Thank you.